Today's lesson is on rectangles, rhombi, and squares. Some of you may have thought the plural of rhombus is rhombuses, and you're actually not wrong in thinking that. Either one, rhombi or rhombuses, is acceptable to use as the plural of rhombus. Just a little bit of trivia there. Okay, don't forget your essential question. And we're going to start with a parallelogram. Of course, we've been talking about parallelograms for a couple of lessons now. We know how to determine whether a quadrilateral is a parallelogram. So we're going to talk about some more specific parallelograms now. The first one being a parallelogram with four congruent sides. That would be our rhombus. That is the definition of rhombus. A parallelogram with four right angles is a rectangle. And a parallelogram with four congruent sides and four right angles is a square. So what does that say about a square? It says that a square is both a rhombus and a rectangle, right? Right. Absolutely. Okay, so you made flashcards for these corollaries, and we'll go over them here. A quadrilateral is a rhombus if and only if it has four congruent sides. The rectangle corollary says a quadrilateral is a rectangle if and only if it has four right angles. Hey, flashback. Does anybody remember if and only if? What kind of conditional statement that makes these? Biconditional statements, right? It means they would be true in either direction. Alrighty, and our square corollary says a quadrilateral is a square if and only if it is a rhombus and a rectangle. So a square is a rhombus and a rectangle. I can only imagine that these corollaries and definitions are going to leave us wide open for some great, sometimes, always, never questions on your quiz and test. I know you're delighted. All right, a parallelogram is a rhombus if and only if its diagonals are, well, we can see from the picture here that those diagonals are perpendicular. So a rhombus has perpendicular diagonals. So in this case, that would tell me that AC is perpendicular to BD. Or, of course, you could write it the other way around. BD is perpendicular to AC. So what do you know about the diagonals of a square? They're perpendicular, of course. A parallelogram is a rectangle if and only if its diagonals are congruent. So we can see there, if we were to name this, let's say E, we already knew that AE was congruent to EC and DE was congruent to BE. Why? Because of the theorem that tells us the diagonals of a parallelogram bisect each other. But now we know if we're talking about a rectangle that the diagonals are actually congruent to each other. So AC is congruent to BD. So what does that tell you about the diagonals of a square? They're congruent. Diagonals of a square, perpendicular and congruent. Alrighty. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So I can see that AC bisects angle A and angle C, and BD, diagonal BD, bisects angle B and angle D. So ABCD is a rhombus if and only if AC bisects angle A and angle C, and BD bisects angle B and angle D. So I guess we could conclude that the diagonals of a square also bisect a pair of opposite angles, each one. Right? Right. Okay, let's decide. Here they are. Let's decide whether the statement is sometimes, always, or never true. This would be a great place for you to pause the video, answer these questions for yourself, and then turn the video back on and see if you got them right. A square is a rectangle. Is a square a rectangle? Sure. And it always is. A square is always a rectangle. Is a rectangle always a square? And guys, remember for these questions, if there's one counterexample, then we have to say that well, no, we have sometimes as a choice here. If these were true or false, remember it only takes one counterexample and we have to say false. But we got sometimes for a choice here. So is a rectangle a square? Sometimes. Sometimes it is. When all the sides are congruent, it is. All right, how about this? Is a rhombus a square? Sometimes it is. Sometimes it isn't. All right, and how about a parallelogram? Is a parallelogram a rectangle? Well, sometimes. Is a rectangle a parallelogram? Always. All right. So you're going to have to, guys, you have to know these definitions and you have to know these corollaries and all these theorems like the back of your hand, or when you go to answer these sometimes, always, and never questions, you're going to have a struggle. Okay, here we go with the true false. The diagonals of a rhombus are always congruent. That's got to be false. Why is that false? Well, because the only time they would be congruent is if the rhombus is a square. So the diagonals would be congruent. This would be true if and only if the rhombus is a square. So guys, before you put down your pencil tonight and turn off this video and you're all done, make sure what I'm telling you makes sense to you. Don't just take your notes and let it go out of your head. All right, number 2, the diagonals of a square are never perpendicular. Diagonals of a square. Wait, aren't the diagonals of a square always perpendicular? Sure they are, so this is false. Diagonals are always perpendicular in a square. Number 3 says each diagonal of a rectangle sometimes bisects a pair of opposite angles. Each diagonal of a rectangle sometimes bisects. That would be true, right? And when is that true? It's true if the rectangle is a square. So true when our rectangle is a square. So when would it be false? It's false if the rectangle doesn't have all its sides congruent, if it's just what we think of as a regular old rectangle. Okay? All right, let's see what we got here, of course. A couple of problems, another good point in the video for you to pause and work these yourself, and then resume watching and check yourself. So I'm given here that EFGH is a rectangle. What is the value of y? Okay, our angle G here, the measure of angle G is 7y plus 6. What do we know about all the angles in a rectangle? They measure 90 degrees. So we know that 7y plus 6 is 90. 7y equals 84. So that tells us that y is 12. QRST is a square. What is the value of x? Well, what do I know about a square? Well, I know all the angles are right angles, but I'm not interested in the angles here. I'm interested in the sides. What do I know about the sides? They're all congruent. Therefore, I know that x plus 27 equals 13 minus 6x. I'm going to get my x's on the left, numbers on the right. So I'm going to have x plus 6x equals 13 minus 27. 7x equals, what is that, negative 14. So x is negative 2. Wait a minute, how can a side length be negative 2? Oh wait, x isn't the side length. If I plug in x, both of my side lengths are still positive. Be careful what the question is asking you. Make sure to answer the question being asked. Okay, we're going to make a list of things we know here. If I got square ABCD, A, B, C, D. I know it's a square. All the angles are right. What else do we know about ABCD? Okay, let's think about what we know about ABCD, the square, because we also know that it's a rectangle and a rhombus. Okay, let's start with a rhombus. What do we know? We know that it's got 4 congruent sides, right? Because the square is a rhombus. What do we know about it because it's a rectangle? We know that all the angles are right angles, 4 right angles. Okay, and how about this? We know that just because it's a quadrilateral, so we know that the interior angle sum is 360 degrees. Okay, let's go back and see what else we know. So this is because it's a rhombus, we know this. Because it's a rectangle, we know this. Because it's a quadrilateral, we know this. Let's think about rhombus again. What else do we know about this square ABCD because it's a rhombus? I'll give you a hint. It has to do with the diagonals. How about this? The diagonals are perpendicular. All right, is there anything else we know about it because it's a quadrilateral? How about the sum of exterior angles? What's the sum of the exterior angles always in any polygon? 360. Exterior angle sum equals 360 degrees. All right, again, what else do we know about our square ABCD because it's a rhombus? Something else about the diagonals. Think about it. What else do we know about the diagonals? We know that the diagonals bisect opposite angles, right? All right. How about this? Don't we know that each interior angle is a right angle? We sure do. And we know that because the square is a rectangle. All right. Another thing about the diagonals. We know they're congruent, right? The diagonals are congruent. Same is true of a rectangle. Okay, so I think we've got the square covered from the rhombus rectangle point of view. So how about just because it's a parallelogram? Let's break it down now. What do we know about all parallelograms? We know opposite sides are parallel. We know opposite angles are congruent. We know consecutive angles are what? Supplementary, right? Supplementary. And what do we know about the diagonals? We know about the diagonals of every parallelogram. They're congruent? No. They're perpendicular? No. We've already got that covered. The diagonals of every parallelogram bisect each other. So remember, what quadrilaterals have we talked about now in which we can say the diagonals are congruent? Square and a rectangle, right? What about perpendicular? What quadrilaterals have perpendicular diagonals? Rhombus and square. Guys, you need to put these on flashcards and study, so as soon as the question is asked, you know the answer instantly. Okay, what else do we know about a parallelogram? The sides. We also know that opposite sides, both pairs of opposite sides are congruent. And lastly, I'll write this here, we know that a square is a regular quadrilateral, right? Because what does regular mean? It means it's equilateral and equiangular. All right, so there's your lesson. Write yourself a good summary. Practice going over these problems again. Practice going over your definitions, corollaries, and theorems. You'll be good to go.